visible? No. Wait. Ma'am, whether my screen is visible?
Yeah, now only it's starting, sir. Yes,
No.
we are able to see, sir.
Okay, ma'am. Good morning to everyone. First of all, I have to thank the management of Alpha Arts and Science College, the founder and chairperson, madam, and the vice chairperson, madam, and the principal of Alpha Arts and Science College for giving me this wonderful opportunity to share some of my knowledge in operation research. Basics we are going to discuss today, and I have to thank Madam Purnalashmi, madam, for giving me this opportunity to interact with you. So I'll go for the presentation. My presentation is on operations research in management. Actually, the students' audience, I heard that BBA, BCom, and BA corporate secretariship, I think so. So the students are actually having the syllabus operations research in their course. So they know the fundamentals, what is operation research, and what are all the types of problems in operation research and how to solve the operation research and so on. So I'm not going to give you how to solve or what are the techniques available and so on, because that will be taught by our faculties. What I'm going to present today is just an introduction about operation research and some two case studies. Some of my students applied knowledge of operation research, that is the techniques they have learned in the MBA program of Anna University Distance Education in the real-time problem. Okay, so those two case studies we will discuss. Since the audience from BCom and BBA, I am going to present the applications towards, say, management or finance-related examples. Then we will get into the subject. Okay. So before that, I will start with the Thirukkural. Okay. So any of you, whether I am audible first of all?
You are audible, sir.
You are very well audible.
Yeah. Thank you. So I'll start with Thirukkural. Okay. Since we are going to discuss about what is management, this management we know, no? Like which consists of some minimum of 5 M's, right? Like men, machine, materials, money, and market, and that is extended up to 7 M's, 8 M's, and so on. So that is those concepts already presented in. Now, whether this screen is visible, that is a PDF.
Yes, sir. Thirukkural, the first slide is
Vinay
visible.
Sayalvagai. Yeah, Vinay Sayalvagai. So Vinay Sayalvagai is one of the.
That is not visible, sir.
That is not visible. Okay, then I have to share my entire screen. Then only it will be visible because I'm sharing my window. Ma'am, I stop sharing and again.
No, the slide which shares. So the slide which has only Thirukkural.
Okay, I can understand. Yeah.
Next
Okay.
slide is not visible.
Yes, ma'am. Just a minute. I'll share my entire screen. Then only it will be easy to your entire screen. I'll share my entire screen. Yes. Chrome wants to share the contents of your screen. Yeah. But I'm not able to get to share the entire screen. How to share, ma'am?
Sir, you click on to that when you click share, no, sir.
Yeah.
One screen
Share
appears.
your.
You have to click on to that and say yes.
Okay. Yeah. Right. Sure. Now now my screen is visible, right now.
Yes, sir.
Just a,
Yes.
all right. Now I go to the PowerPoint presentation. Now it's visible, man.
Yes, sir. VN செயல்
Yeah.
வகை. Yes. வினை
Vinay
செயல் வகை.
Sayalvage. Vinay Sayalvage. I think audience know Tamil, so I am giving you few couplets, which is taken from Thirukkural. Okay, ஸோ திருக்குறள் எல்லாருக்கும் தெரியும்னு நினைக்கிறேன். ஏன்னா திருக்குறளில் பார்த்தீங்கன்னா அந்த வினை செயல் வகை அப்படின்னாவே தட் இஸ் ஆப்ரேஷன்ஸ் ரிசர்ச். ஓகே, ஆப்ரேஷன்ஸ் மீன்ஸ் the tasks that we are going to do. Research, that is the methodology, how to do it, or we can find out the methodology to solve it. So that's why that operation research can be interpreted as Vinay Sale Vagay, ஒரு செயலை செய்யும் முறை. Okay, so I have taken the couplet 675 from Thirukkural. பொருள், கருவி, காலம், வினை இடந்து, ஐந்தும் இருள் தீர எண்ணி செயல். This is the concept behind management. Whenever if you want to do any business, okay, if you want to start any business, these are all the major things. That is porul, right? So you can say the finance, right? Money, porul, money. Karuvi, the tools or machines, whatever you want. Kalam, the time, when you have to start, and all these things. Vinay, that is how to do, the methodology. Okay, so you can say technology and so on. And idam means that is a place. So you can say the where you can start your business, which is like your market. So where is the market? So the 5 M's we mentioned in the management concepts, that is fantastically explained in Thirukkural. பொருள், கருவி, காலம், விடை, வினை, இடம், இவை ஐந்தும் இருள் தீர எண்ணி செயல். So the next one, what I'm going to present you is, this is your definition of linear programming problem. So you are all the students actually studied or studying linear programming problem in your applications research. In the linear programming problem, the components of the linear programming problem are three. One is your decision variables. Second one is your objective function. Third one is your constraints. So whenever if you solve a problem, you need to identify the decision variables. What are all that you are going to find out? What is your unknowns that will be represented in the form of x, y, z, or x1, x2, x3, and so on. So the decision variables. The next one is your objective function, right? So whether you are going to maximize or minimize, that optimization. Okay, so the profit may be maximized and the loss may be minimized. And the third one is the corresponding constraints. The constraints may be in the resources, okay, the resource constraints. See, in this Thirukkural 676, that is the definition of linear programming problem, which is fantastically correlates with the linear programming problem components. முடிவும், இடையூறும், முற்றியாங்கு எய்தும், படுபயனும் பாக்கு செயல். செயலை முடிக்கும் வகையும், that is the methodology, right? The procedure to solve. முடிவும் means that is your result. So whatever you are going to find out, that decision variables. இடையூறும், you know what you mean by இடையூறும்? That is the conditions or constraints. What are all the constraints that you have? இடையூறும். முற்றியாங்கு எய்தும், படுபயனும். That is what is that you are going to achieve? Either maximize the profit or minimize the cost. So these are the things to be considered while solving any problem. So it's fantastically defined by Thiruvallur in Thirukkural. In the same chapter called Vinay Sayal Vagai, the couplet number is 676. Okay, so this is another thing we need to appreciate from Thirukkural, correlated with your linear programming problem definition. This is the concept, again 678, வினையால் வினையாக்கி கோடல், நனைகவுள் யானையால் யானையா தட்டு. தட் இஸ் ஒரு செயலை செய்யும் போது அச்செயலை மற்றொரு செயலையும் செய்து முடித்து கொள்ளல், ஒரு யானையால் மற்றொரு யானையை பிடித்தலை போல அப்படின்றது விளக்கம். Which means this is the concept of duality. So I think in the methods of solving linear programming problem, one of the fantastic concept is duality. Duality means you can write the dual problem for the given primal problem in the linear programming problem, so that dual problem can be solved, and from the solution of the dual problem you can find the solution of the primal problem, the original problem. So that is, you are solving the original problem by converting the original problem, primal problem, into real, and then solve. So the concept matched in this couplet. So I have taken this for reality concept in linear programming problem. And one more couplet I have shown to you, that is தூங்குக தூங்கி செயற்பால தூங்கற்க தூங்காது செய்யும் வினை. So this couplet correlates with your critical and non-critical activities, that is in your project management or your critical path method. So you have studied, or you are going to study maybe the critical path method, that is a project management concept, how to plan the project management to complete the entire project in minimum time. So in that there is a methodology called critical path method. In that you will be identified that critical activities and non-critical activities. So what do you mean by critical activities? The activities should be start and complete in time. So you should not do any delay in these critical activities. In the case of non-critical activities, you may have a float, either total float or free float, which is the slack time that you can leisurely do the activity within some stipulated time. So காலம் தாழ்த்தி செய்யத்தக்கவற்றை காலம் தாழ்த்தியே செய்ய வேண்டும். This is for your non-critical activities. காலம் தாழ்த்தாமல் விரைந்து செய்ய வேண்டிய செயல்களை செய்ய காலம் தாழ்த்தக்கூடாது. That means you have to do the activities in time. So those activities are critical activities. So this is for critical and non-critical activities, which is your project management concept. So how to plan your activities using the operation research tool called critical path method. Okay, we are going to see one illustration in that also. One of the case study applied by one of my MBA project student in the real time problem. Okay, so the last one, last couplet, this is the last couplet. Volva ellam vinay nandre volla kal selluvai nokki செயல். So this is from the same chapter, vinay செயல் வகை, couplet number 673. The explanation is ஏழுமிடமெல்லாம் ஏழுமிடத்தில் எல்லாம் செயலை செய்து முடித்தல். ஓகே, நல்லது. இயலாவில்லை என்றால் பயன்படும் இடம் நோக்கியாவது செய்ய வேண்டும். So whenever if you do any work, any plan, okay, so any research, actually this is more applicable to the research. Okay, since I am explaining the concepts of operation research, I thought that some of the students may go for further studies and research, or some faculties may do research or doing research. Okay, so in that case, whenever if you do research, when you can take a new problem and find apply a existing procedure and find the solution. This is one type of research. Another type of research is you can solve an existing problem, apply a new method, find out a new method, and then find a solution. So that is also a type of research. Some other type of research is you have to identify the problem itself, a new one, and the solution methodology also a new one. Then you will get a totally different methodology to solve. So this is one of the concept of explaining how to do the research, or how to solve any real-time problems in the industries or in management. Okay, so I'll just close this. Whether this is interesting to correlate Thirukkural with operation research. Any response for this? Any response from the students? Students, do you enjoy the Thirukkural couplet which is correlated with operation research? Since I am not able to straight away contact you in person, I'm just asking. Say yes or no. Some response.
If you can unmute and say, or you can put it in the chat box. Sir, at the end of the session, we have question and answers, sir.
Okay, ma'am. Okay, ma'am.
And if you want to ask anything in between, you can write it in the chat box. You can post it in your chat box.
Okay, ma'am. Right now, the definition of operation research consolidated by Gupta and Hira. So I have taken this from Gupta and Hira. There is no particular definition of operation research. So every author defined operation research in different manners, Taha and Lieberman and so on. So this is the consolidated one. So whenever if you say operations research, can be considered as being the application of scientific method by interdisciplinary teams to problems involving the control of organized, right? So that organization may have man, missions, and so on systems, so has to provide solutions which best serve the purposes of the organization. So it's an interdisciplinary subject actually. Operation research is not only a basic mathematics. It's started from the basic mathematics, which is applicable, applied mathematics to application to all the fields. Not only in management, we are going to discuss some of the fantastic examples in management, which is directly applicable, applied by the operation research tools. Apart from management, you can apply this operation research in all the fields, day-to-day lives and any industry problems. Okay, so production problems, and even whenever if you want to go for any planning activity, right? So if you want to construct a home, if you want to construct some bridge, okay. So whenever there is a planning activity, uh, then the operations research tools, the techniques, optimization techniques, which is very much helpful in planning and executing, getting the results in a scientific way. Okay, so it's an interdisciplinary subject. Okay, so it's not only based on mathematics. So our application is in the many fields. Okay, so I have taken one simple case study just to visualize, how to formulate the case study, which is actually this case study taken from interfaces. That is a journal site called interfaces. So in that I have taken post office problem, but mm, this can be applicable to this post office problem can be reformulated to uh, what is called human resource planning, right? Human resource planning, scheduling, right? So you can manpower scheduling. So this problem also called manpower scheduling. So this is applicable not only in post offices, which is applicable not in our Indian scenario. This post office in the 24-hour, what is called 24-hour working post offices, no, head post office in those places. Apart from that, in the hospitals actually, nurses and doctors are working 24 bar 7, right? So whenever if you want to schedule human resource planning, this example will be very much applicable in the human resource management. So you can say HRM. Okay. So a post office requires different numbers of full-time employees on different days of the week. The number of full-time employees required on each day is given in the following table. So the resource person's requirement is on Monday 17 number of full-time employees required, Tuesday 13, Wednesday 15, and so on. So some data is given, right? So these are the number of persons required on each day. Okay. So the further instructions given in the problem is union rules states that each full-time employee must work 5 consecutive days. So whenever if an employee starts working on Monday, so he's going to work throughout Monday to Friday, then he may take 2 days leave at the weekend, that is Saturday, Sunday. Suppose if he starts working on Tuesday, so he may take from Tuesday to Saturday he has to work, and Sunday and Monday he may take leave. So must work 5 consecutive days and then receive 2 days off. So for example, an employee who works Monday to Friday must be off on Saturday and Sunday. Likewise, if he starts on Tuesday to Saturday, like that. And so on. So the post office wants to meet its daily requirements using only full-time employees. Okay, so formulate this as a operation research problem. Like I'm going to formulate this as a linear programming problem. Uh, to so as to minimize the number of, so this is our objective. The objective here is to minimize the number of full-time employees who must be hired. Okay, so the number of employees which is actually required should be minimized. Okay, so this is a human resource problem. See how which is actually formulated. Let x1 be the number of people beginning work on Monday. That means if they starts on Monday, they have to work till Friday. So this x1 going to be constantly working from Monday to Friday. Suppose X1 equal to 10, you assume. Then Monday, 10% started working till Friday. Okay. In the meantime, Tuesday, some set of people will come and join. Okay. So those people will work from Tuesday to Saturday. They will take off from on Sunday and Monday. So like that. So every day, Monday, Tuesday, Wednesday, each of the day of the week, a set of people will join and work. Okay. So the objective function is to minimize. Objective function is to minimize the total number of employees, full-time employees for the week. So that can be found out by, so that is represented by Z, which is equal to number of employees who start work on Monday uh, plus the number of employees who work start on Tuesday and so on till the number of employees who start work on Sunday. So each one is represented by X1, X2, X3 and so on up to X7. Okay, so you have to add, these are all the number of persons. Okay, so obviously it should be positive and greater than or equal to 0. So it may be 0 or more than 0. So non-negative, you have to imply the conditions. So the constraints here is in the first table itself we found out Monday 17 employees must be working. So on Monday 17 employees working means Monday who will take off those who have started working on. So I am just using my cursor to point out Tuesday and Wednesday. Those who are joined work on Tuesday and Wednesday, they will take a leave that is off on Sunday and Monday, because those who are starting working on Tuesday, they will take off on Sunday and Monday. Similarly, those who are starting Wednesday till Sunday, they will take off Monday and Tuesday. So, working the number of persons working on Monday, these two employees, that is those who are joining on Tuesday and Wednesday, they won't work on Monday. Therefore, you have to exclude them. Okay, so I have not included X2 and X3. X2 representation of number of employees who is joined or start work on Tuesday, and X3 is the number of persons who is starting on Wednesday. So I have excluded X2 and X3. The reason is they won't work on Monday, because we are actually calculating who is working on Monday. Okay, so it will be like X1 plus X4 plus X5 plus X6 plus X7, and there is a requirement minimum 17% required to work on Monday. Minimum means it may be more than 17 also. So there is a greater than or equal to constraint. Similarly, I'll just explain the remaining. So for each day, there is a table in the beginning. At the beginning, 17, 13, 15 number of employees required on that particular day. So that can be calculated by using these constraints. So after this formulation, okay, this is a linear programming problem. Okay, so this is the basic problem, very first problem in the operation research. Whoever studies operation research as a course in your program, okay, so in that the first unit obviously consists of linear programming problem. So I have given an illustration from human resource management, HRM, human resource management. So this can be applicable not only in post office, so it can be applicable to hospitals, okay, doctors who is working for 24/7, nurses and so on, so many places. Okay, next. The solution for this is actually solved already. So there's a example solved, and the solution is that is optimal solution by any simplex method or any methodology which is applied. 67/3 is the minimum number of numbers. So it's a fraction. There is no meaning in getting x1 is equal to 4/3 means it's approximately 1.333 and so on. So on Monday, we require 1.33 employees means it's meaningless. So it should be integerized. It should not be a fraction. So there is a methodology called integer programming problem. Some methodology like a Gomori cutting plane algorithm or branch and bound algorithm, which is applied, and we found out the integer solutions, not only non-negative as well as now integer solutions. So x1 equal to 4. That means 4 number of persons should start working on Monday, and 4 number of persons should work on Tuesday. To, their work should be charged and so on. So this 4, 4, 2, 6, 0. So 5 means Friday, right? So Friday, no person required to start their work because already existing persons is enough, and the total number of employees required, that is minimum total number of employees required is only 23 based on the given cases. Okay, so this is a fantastic application in the human resource management problem, and which is having some 7 variables and 7 constraints. So it's a very big problem. Solving manually takes a lot of time, but you can solve by using any fantastic existing softwares. Okay, like Torah, um, your linear programming solvers. Okay, so shall we pass on to some more applications? So further applications, one application I want you to show. Since some BCom students and BBA students, there are, I have some 3 applications. So I go to the finance application in person straight away, okay, directly, and I want you to these are all the practical problems actually applied in the real time. I have taken these case studies from the interfaces, that is a journal, okay, publishing. Real-time problems case study. So I have taken this. So this is a financial application. The financial application here is portfolio selection. Okay. So in the like in share markets, so whenever if you want to invest your money in stocks and bonds or in share market, so how to select the portfolios. Okay. So we can again formulate this as a LP. LP means linear programming problem. Okay. So the LPP can be used in financial decision making that involves capital budgeting, make or buy, asset allocation, portfolio selection, finance planning, and etc. So many applications are there for the linear programming problem itself. So in that, I'm going to take portfolio selection. Okay, so in the portfolio selection, the problem here is this type of problem is faced by the managers of banks, mutual funds, and the insurance companies. Okay, so the agents, who is investing in the shares, even if it may be mutual fund managers and so on. The objective function usually is maximization of the expected returns or minimization of the risk. Obviously, so whenever if you want to go for an investment, you will expect a maximum return, and the risk should be minimized. Okay, so the problem here is some person, Winslow Savings, has $20 million available for investment. Okay, it wishes to invest. So that is a company, Winslow. Okay, it wishes to invest over the next 4 months. So make a note of it. It's the next 4 months in such a way that it will maximize the total interest earned over the 4-month period, as well as have at least $10 million available at the start of the 5th month for a high risk rise building venture in which it will be participating. Okay, so here for the time being, Winslow, that the organization wishes to invest only in two-month government bonds, which is actually earning 2% over the 2-month period, and 3-month construction loans, which is earning 6% over the 3-month period, and each of these is available each month for investment. Okay, so actually the 4 months, they are going to just invest only 4 months. All the 4 months, these 2 type of investment, 2-month gold bonds and 3-month construction loans are available. So funds not invested in these 2 investments are liquid. Okay, so liquid cash, and earn 3/4 of a 1% per month when invested locally. So like through fixed deposit, something like that. Okay, right. Now you have to solve this problem. How much that Winslow should invest on what you call the 2-month government bonds and 3-month construction loans, and the remaining should be in the fixed deposit, something like liquid cash. Okay, so these are the 3 types of investments. So formulate a linear programming that will help Winslow saving determine how to invest over the next 4 months. Okay, so I wish to have more than 8 million in either government bonds or the construction loans. So that is also another constraint. So if at no time does it wish to have more than $8 million, so it should not be more than $8 million in those two type of investments like government bonds and the construction loans. So based on these constraints, so this portfolio selection may be formulated. The decision variables I told, the components of the linear programming problem are three. The first one is the decision variables, the second one is your objective function, and third one is your constraints. So the first one, decision variables, GI representation of the amount of investment, new investment in the government bonds in month I. Okay, so there are 4 months investment. Therefore, I is equal to 1, 2, 3, 4. So G1 means in the first month how much amount has invested in the government bonds, and C2 is nothing but the amount new investment in the construction loans in uh, month I. Okay, and LI is the amount invested in the local, like fixed deposit account in the month I. So there are 4 months, three type of investments represented by G, C, and L. That I is the index representation of the month. Okay, so that means you have some 3 into 4, 12 variables. Try to understand, there are 12 variables: G1 to G4, C1 to C4, L1 to L4. Okay, next. Uh, the objective function is obviously maximize, So the maximize the total interest earned in the 4 month period. So the returns, interest is nothing but the returns. So interest rate on investment should be multiplied by the amount invested, obviously. So the interest rate already mentioned, yeah, government bonds means 2%, and in the case of loans, corporate loans, that is 6%, and so on. And for the locally investment L, it's 3/4 of 1%. So all these things are your rate of return, interest rate, that is your return, and the amount invested that we are going to identify by G1, G2, G3. So we are going to maximize. You can take Z is equal to, Z is the total interest or the return, okay, in 4 months, which is equal to obviously the 0.02 is the 2% of your returns from the government bonds. Therefore, you multiply this G1, G2, G3 by 0.02 and find the total return. And in the case of loans, that is 0.06, that is your 6%. You multiply with C1, C2, C3, and then find the sum. Similarly, the next one is your local investments. That is your 3/4 of 1%. So it's 0.0075 into the remaining. So you have, I told us, 12 variables, right? So that is your objective function. Now the constraints. Constraints actually is having that organization having only $20 million. So that G1 plus C1 plus L1 for the first month, it should not exceed 20 million. So it should be equal to 20 million. So in the second month, the investment will be not only 20 million. So there may be a return, interest invested locally in the month one. So that is also included. So that is 1.0075 into L1. So these are all the constraints. I'll show next third month constraint and the fourth month constraint. So then after formulation, another constraint given in at the end of the problem we have mentioned, that is no more than 8 million in government bonds and at any time. So the government bonds, represented by G1 to G4. So it should not exceed $8 million. So therefore, these four more constraints, already 5 constraints included. This is 4 more constraints. So totally 9 constraints, 12 variables, 9 constraints. Apart from that, no more than 8 million in the construction loans also, right? So another 4 constraints included. So totally 13 constraints with 12 variables. So it's a very big problem. To solve this, you can apply any solver, okay, any linear programming methodology to solve. So all the variables, G1 to G4 and C1 to C4 and L1 to L4 should be non-negative, obviously, because those are all investments. The negative value for an investment is meaningless, so it should be non-negative. So after solving this, these are all the results obtained. That is around 14 lakhs, 29,213 dollars. That is the returns after this investment. So the values are G1 to, there are 12 variables. It's listed in the first column. Second column, the corresponding values it obtained from it. So there is no reduced cost. Okay, so this is another application just to visualize how this operation research, the linear programming problem, is applicable to portfolio selection problem also, right? So it's a financial management problem. So one more application I have mentioned. Okay, shall I proceed? Yes. Ma'am,
Yes,
how
sir.
much time
You
I
can
have
proceed,
remaining?
sir.
Shall I take 15 more minutes to complete?
Yes,
That
yes.
is up to 11
You can do
o'clock.
it, sir.
Yes. I have two more case studies. These are all the case studies done by my MBA project students. Am I audible?
Yes, sir.
Ma'am, am I audible?
Yes, sir. You're audible, sir. And we are able to see the screen also.
Ma'am, am I audible?
You're audible, sir.
Okay. So I'll go to the case studies. I thought I'm audible. Take this case study. The case study, what I'm going to present now, is a case study done by one of my MBA project student from Anna University. Okay, so the title is a study to optimize the Premium in software product implementation timeliness for the Blue Shift Information Systems Private Limited. So there is a software organization Blue Shift Information Systems Private Limited. The problem he found out from that organization is the timeline. Okay, so timeline to complete a project. So the project I showed just take the actual problem, right? Problem definition. This is the identified problem. The software implementation timelines is very crucial for any implementation and transformation of customer business from existing application software to new software within the defined or agreed timelines. Here, the application software implementation timelines are extended due to various activities involved in the overall implementation of the life cycle. So, whenever if there is a software development, there is a software development life cycle. Okay, so it starts from collecting the data till completion of the project. That is deployment of the project, implementation of the project. So there are various steps in the software development lifecycle. So that the timeline is extended due to so many reasons. These issues are analyzed with the secondary data to optimize the problem. Usually, what he has observed in the mid-size insurance software products, the timelines is between 150 to 200 days. Okay, 150 to 200 days. What he wants to do, he wants to minimize the time and by eliminating some or some clubbing some of the procedures or the methodologies steps together or parallel processing and then try to complete the entire project within 100 days. Okay, so this is the study we have done. In this, what happened, I'll show the cycle, right? So this is are able to view this figure. I'm sorry, it's upside down. Start of the project, and the first step is business solution mapping. And for that step, there are 45 days required, and FSD preparation requires 30 days. Okay, and the next step is core user training requires 20 days, and the next step is end user training requires 15 days, and the next step user acceptance testing requires 30 days, and the uh, parallel run, that is implementation process, is 30 days. So finally live run. So if you just add these number of days required to each stage of the software product development life cycle, it is around 30 plus 30, 60 plus 15, 75, 20, 95, and 125, and then one 170, around 170. So this figure represents the existing implementation flow with duration. So around 170 days, requires to complete the task for a particular software development for the insurance sector. But what is our objective is it should be reduced. Okay, it should be reduced to 100 days. So using our PERT, I'll go to the methodology in straight away. He has done extensively by doing literature survey and the proper research and collecting the data and so on. And just scroll down the entire project report. I'll go to the technology that he has used, to solve this actual practical problem, and he has implemented in the industry. See, he has taken the brainstorming from various stakeholders of this problem, that is the delivery head, the project managers, project leaders, quality leaders, business analysts, development team members, and so on. So from them, he has taken the brainstorming sessions and he has tried to apply project evaluation and review technique. This is one of the what is called operation research technique or tool, project evaluation and review technique, which finds the minimum expected time to complete the total project. Okay, so in that you can go for the cost reductions also, crashing the project network with cost trade-off also, and the resource leveling. So the number of human beings or the persons resources required to complete each stage, each task, or each activity. So these things he has applied. Apart from that, data decision analysis and resolution and casual analysis meeting. So these are all the technologies he has applied and found out the solution. I don't want to explain what is project evaluation and review technique because it's available in your course, right? So you are studying operation research as a course in your program, BBA or BCom. In that, this part definitely will be there because I have asked your teacher, it's available in your syllabus. So I want you to show fantastic live application. We applied, and found out the result. So I'm just scrolling down the project report submitted by Jnana Sambandha. Okay. So see, there are so many steps involved. We cannot straight away identify the data. So you have to collect the data from the stakeholders. Okay. See, I'll show this table. In this table, sorry again, in this table, there are some 7 activities defined. Activity A is business solution mapping. Activity B is functional scope document, preparation for the change request, and activity C is core user training. Activity D, end user training. Activity E, user manual preparation. And activity F is user acceptance testing. And G is your parallel run. So from the stakeholders, he has identified what is the I am just highly showing my using the cursor. I'm just highlighting that optimistic and most likely and pessimistic time. So he has found out 3 different time limits, and then he found out the mean, right? Mean, a plus 4m plus b by 6, that is the formula to find out the mean, and the variance b minus a by 6 the whole square for each activity. And after that he wants to minimize, right? So he wants to club. So I'll go to the result straight away. Okay, so this is a methodology he has applied. I wanted to show. So this is your network diagram. Whenever if you go for a CPM or per type of problem, okay, critical path method or project evaluation and review technique, you will draw a network diagram to represent all the activities and the corresponding durations. So here the durations in the bracket or the expected duration, that is the mean duration from among the optimistic, most likely, and pessimistic time. So A, B, C, D. So the predecessor and the successor also mention a hierarchy which should be done first and which should be the succeeding activity and so on. Based on that, he draw the network diagram and he found out the critical path as A, C, D, F, and G. So the red activities, red line, red marks are the critical uh, path. That critical path start from the node 1 to node 6. Okay, so it took some 24 average expected duration. So number of days, obviously. Okay, 24 weeks. I'm sorry, 24 weeks. So after analyzing that, he has the model what he has tried and proposed and implemented is speed model implementation. So in that, instead of 7 activities, he reduced it to 4 activities. The 4 activities are A, B, C, D. A is a business solution mapping, and B training, and C1 is user acceptance testing, and D is parallel run. Then in that he reduced. I'll come to the critical path. I'll come to the critical path, and he has applied crashing techniques to reduce the cost also. I'll go to the result, straight away I'll go to the result because of the lack of time. I wanted to show one more case study what he has done. That is used the knowledge of operations research in the management concept. So that's why I've taken this case study. I'll go to the result, straight away go to the result. I'll show you the, uh, he is able to solve the problem, that is complete the project within 100 days. Within 100 days. Yeah. So the findings, these are all the findings, right? The findings is implementation timelines has been fixed to complete it within 100 days. So instead of 170 days, he reduced it to 100 days by what is called clubbing some of the activities together. So, yeah, this way. I want to show this final set of activities for speed model with the duration. So previously I have shown you some 7 different activities consists of 170 days to complete the project. Now that is clubbed and reduced based on the PERT technology, project evaluation and review technique that you are studying in your course, directly used to reduce this total project completion time to 100 days. See, business solution mapping only 30 days, and trainers training 20 days, user acceptance testing 25 days, and parallel run for 25 days. So if you just add, and you will get 100 days. So actually he has implemented this in the real time also, and he is able to complete within 100 days. So it's a straight application, direct application of whatever you have studied in your course in the what is called planning activity, right? Timeline, project management activity. So it's a project management problem, right? So any software should be complete as early as possible. So I'll take one more case study. Shall I take 5 more minutes, ma'am?
Yes, sir.
Ma'am, shall I extend 5 more minutes?
Yes, sir.
Am I audible?
You are audible, sir.
Shall I take 5 more minutes? One more case study, shall I show?
Yes, sir. You can show, sir.
So the next case study I'll just complete within 5 minutes. Don't worry. So that is done by Mr. Ramanan. Actually, he has worked as a South Asia manager, marketing service center manager. Okay, so one of my MBA project student at Anna University he did this project for HP, Hewlett Packard service centers. Okay, you know Hewlett Packard HP is a hardware manufacturer, computer laptops. So they are calling that as notebooks. Laptops called as notebooks. So those notebooks come to a particular service center. He has taken a particular service center called service center at Hyderabad. Okay, so in that what the problem is, I'll show the problem straight away. I'll go to the definition of the problem. Right? The problem is the yeah identify the problem. So these are all the data given by him. In the notebook PC service center, notebook is nothing but your laptop. Okay, PC service center, customer waiting in high, and due to this delay, customer not happy about the service center operations. Also due to duplication of work in the front desk, productivity of engineer is wasted. To avoid these problems, it is essential to automate service center walk-in process and to have the customer database in the computer and to use that for the future business opportunities. So actually what is happening in the service center is the customers are waiting in high waiting time is high, so sometimes they are not able to complete the number of notebooks arrived for the service within the day itself. Sometimes they want to extend the notebooks to the second day also, so their working time is start from morning 8 o'clock till evening 6. So morning 8 to 6 with some lunch breaks and half an hour. So they have to work. So there are some what is called only one service person, okay, who is receiving the laptops. Actually, there are two persons who is taking care of the notebook service centers. One is for the warranted notebooks, another one is for the unwarranted notebooks. That means the laptops. So the laptops which is in warranty, which will be serviced free service. Another one is paid service. So two persons taking care of this receiving the laptops for service. What happens? High queuing length. Then we modeled this as a queuing theory model. I heard that queuing theory also available in your course. We applied it practically, fantastically applied, and that is called MMC model, Markov model with multi-server queuing process model. I'll show you the results. Finally, I'll show you the results. So this is a queuing system model. I'll go to the results straight away. I'll go to the result because it's running out of time. I'll show the results here. What he has done is initially this is the current process. Okay, so this flow chart gives the current process service process in the service center, PC service center. The current process is customer walks into the service center, hand over the laptop to the information, that is to check whether that is a free service or paid service, and then it will go to the next step and so on. So what he has done is this is the proposed and implemented. Actually again this is implemented, okay, in the real time, and reduced the customer service waiting time drastically. So T terminals, since it's a HP service center, uh, they are able to put automated systems, in the receiving terminal. So in that, the once if the customer walks into the service center, he enters the details in the terminal provider. Application software display warranty status and token number. So he has to check whether that is in the warranty or not in the warranty period, or and identify the token number. Then from the three terminals, he can immediately finish his work. If the customer asks you to wait in the lounge, then he can. Otherwise, some of the things, can be solved by the automated system itself. We can just get it cleared from the system, no need to give the laptop to the service person. Sometimes it may be a software related problem, not the hardware related problem, that can be diagnosed by the automated system, and then you can go out of the system. That is, you cannot enter into the queuing process. I'm calling the queuing process as a queuing system. Next, second one is, if suppose if he requires help of the service person, that is, if it is a hardware issue, then he has to enter into the system and then solve the problem. So what happened after applying that queuing model? There is a reduction in, see, I'll just show you. There is by implementation of the automation can save the operational cost of rupees 20,000 per month. So for that, only one service center, one particular service center from Hyderabad, that is a HV service center, he is able to, after this application of the queuing model, multi-server queuing model, he is able to reduce 20,000 rupees per month for the particular service. So if you extend this for all the service centers of the HP throughout India, throughout the world, what will happen? The reduction in the operational cost will be in lakhs. Okay, so this is one of the application of your queuing theory in real time. Okay, so after this, I'll just stop there. I have just shown you two case studies. That's all. Okay, so I want to just show you the references. These are the references I have taken. Okay, the next one. This is one project is from Ramanan, another one is from Assam. So, do you have any questions? So this is a time for questions. So you can just unmute and ask. Otherwise, you can ask those doubts in the chat box also. Shall I open the chat box now? So shall I stop sharing my
Yes, sir.
screen,
Yes, sir. You
ma'am?
can stop sharing. Students, those of you who have any questions to ask, you can post your questions, or you can unmute yourself and ask the questions. Those of you who want to
Okay.
ask anything
So
now,
any queries from the audience, students? Give me some comments, feedback, whether this presentation is useful to you. Give some additional knowledge, addition in your course.
you can post your comments in the chat box.
No questions? Give me some feedback. Unmute yourself and then give your feedback. I'm eager to listen to your feedbacks about the session. One or two. The students who are organizing this, you can give you comments. I'm expecting some critical comments also. Thank you. Thanks a lot for your patient listening. Thank you very much, ma'am.
I think they don't have
Okay,
much
I'm
to
able to
ask, sir,
read some
because
of
the case
the
studies were
chat
very clear.
messages. Shamila says very useful and informative. Ask any doubts related to the applications of operation research tool. You can
BBA
answer through
students
chat
can
box
link
also, no issues.
BBA students can link this OR also in your project in the third year. So
Whether
if you
you
have
people
any
are actually
doubts,
studying operation research or studied, already studied. You
both
must become
categories are there,
second
sir.
year
Third BBA are there. They
students.
have already studied OR in
It's
the
presently
previous
in your
semester.
syllabus now or already completed the course. Just answer through chat box. Yes or no. Say yes or no. That is whether you are studied or you are studying.
Post in the chat box whether you are doing OR this semester or you have completed OR.
Oh, okay, very good. Studying. Thank you for your response. Gayatri, Sharmila, Vasudevan, Gautam. Good. So I have taken some of the case studies, which is from applications of tools from your syllabus, like critical path method, that is PERT, that is already existing in your syllabus, and queuing theory. These two are in your syllabus. So we have implemented it actually through the MBA students. I have some good case studies in the inventory model and scheduling, sequencing problems also. We
Sequencing
did it
problems.
for Ford. Okay, Ford manufacturing. At
Okay, we
present,
are planning to take them to
it's not in
IB, sir.
Maramalai Nagar. Previously, the Ford manufacturing uh, plant was in Maramalai Nagar. For that organization, we did two projects. One project for reducing the inventory carrying cost. This next one is to reduce the operational cost in the painting section. Okay, through again enhanced English. So you people are doing good.
So they don't
All
have
the
much to
best.
ask, I think. Shall we move on, sir?
Any doubts, any queries? Purnalakshmi ma'am.
Thank,
Yes, sir. Shall we move on, sir? I don't think they have anything to ask because it was very clear. So, shall we move on to the winners list, sir?
thank you, sir, for sharing your valuable knowledge with us. That was an amazing session. I kindly request, let us now have a look at the winners of the competition. First, number rudeness competition. First prize goes to C. Sandhya of second BBA. Second prize J. Hariharan of second BCom General. In hide and seek competition, first prize goes to Tina Jasin, second BBA. Second prize goes to second BCom General Deepak. I now call upon Ms. Sharmila of second BCom ISM to deliver the vote of thanks.
Good morning to one and all logged in here. It's my privilege to propose the vote of thanks on this special occasion. I, on behalf of Department of Mathematics,
So I
first
thank
of all,
the organizers, the college management, and particularly Purnalakshmi ma'am for giving me this opportunity to just share my experiences and knowledge with you. Thanks a lot. All the best, students. Thank you.
good morning to one and all logged in here. It's my privilege to propose the vote of thanks on this special occasion. I, on behalf of Department of Mathematics, first of all extend my most sincere thanks to the Almighty. I extend a very hearty thanks to Dr. S. Karthikeyan, Assistant Professor, Dr. Ambedkar Government Arts College, Vyasarbadi, for his valuable time and informative session. Thank you, sir. I wish to express my gratitude to the Chairperson, Dr. Ms. Grace George, and Vice Chairperson, Ms. Sudha George, in their absentia, for providing encouragement and support for us. I also wish to express my sincere thanks to our principal, Dr. Shivashankar, for being the source of encouragement and for giving us an opportunity to organize this webinar. I extend a very hearty thanks to Dr. Benita Merlin, Vice Principal, and Dr. Tamilarasi, Shift 2 Coordinator, for being our driving force. I owe special gratitude to the professors and students of our college for your active participation. I owe my special gratitude to the non-teaching staffs who worked hard to ensure that this event becomes a grand success. Once again, I thank you all. Thank you.
Thank you, Sharmila. Ends are not bad things. They just mean that something else is about to begin. Or they are, and many things that don't really end anyway. They just begin again in a new way. We once again thank you all for your presence and support. Thank you. Participants, kindly turn on your video for taking a picture. I repeat, participants, kindly turn on your
I'm not
video.
able to hear.
Sir, can you able to hear?
இல்லப்பா எனக்கு எதுவும் கேட்கல.
Sir, now
Sorry.
can you able to hear?
Can you hear, sir?
Maybe wait a minute. Just a minute, ma'am. I'm sorry. I'll just yeah. இப்போ சொல்லுங்க. Now you can speak.
Now can you able to hear me, sir?
Okay, you carry on because I'm not able to hear. You just carry on.
Participants, kindly turn on your video for taking a picture.
What I have to do? Can you hear, sir? No, I have not. Okay, vote of thanks over. Okay, no issues.
Yeah, okay, we will now call off the meeting. Thank you. Thank you all.